Today's video is function transformations number 1 and number 2. So the first thing we're going to do is talk about just how functions move. This is just how functions move around a graph based on the parent function. So in these problems, the first value, f of x, is our parent function. So notice how g and h both can clearly see x squared. And what that means is the parent function is intact, meaning nothing is inside of it. So the value on the outside shifts the function up and down. So since this is a positive 3, the g of x function just basically goes up 3. So what that's going to do is it's going to take the x squared function and slide it up 3. So if you're stuck on these, you can always just graph them. So I'm going to pull this down, and I'm going to graph x squared as blue, and then x squared plus 3 as red. So as we graph, notice how we have our regular x squared function, and then the red is x squared plus 3. Notice how the blue function has shifted up 3 units. So if you're ever confused on function transformations, you can always graph them. This next one is a negative 2 on the outside, and what that's going to do is it's going to go down 2. So that's going to shift the function down 2, and what I will do is I will go ahead and also graph, I will also graph that one as well. So that one will be black. So notice how that blue function shifts down 2. The difference in this problem versus this problem is the x squared function is not intact, meaning stuff is happening with it with the plus 3. Now, these can be very tricky because the value is inside. When it's inside and adding, that is going to the left 3. If it's inside, I probably should not be using all these arrows. If it's inside and negative, then what's going to happen is it's going to go to the right 2. So the opposite of what you think happens is how the function shifts. So what I'm going to do down here is I'm now going to graph the other parent function like this. So I'm going to graph g of x red and h of x as black. Oh, squared. Oh my goodness. Okay, there we go. Let me just start over. It's a struggle, guys. There it goes. Okay, so to graph, blue is the parent function. That's the original. G of x will be in red. Notice how it shifts to the left 3. And h of x will be graphed in black. Notice how that one shifted to the right. So whenever you're adding and subtracting inside of the parent function, it's actually going to go the opposite direction of what it looks like. All right, see? This one, the parent function looks a little bit different. The parent function is x cubed minus x. So notice how in these two, the parent function is intact, and we just have these values off to the side. So g of x, and I'll go ahead and just do it this way. G of x, we're going to go up 1. H of x goes down 2 because it is outside of the parent function and negative. The difference here in D, notice how the parent function looks different. Like this value is the parent function. Notice how g and h look different from g and h up here, and we have values inside. Since there are 2 variables, you have to write the direction twice. So on G, all I'm going to do is say that this goes to the left 1. That's it. Even though it's written twice, it's only moving one direction at one time. H, I write the negative 2 twice, so that means it goes to the right 2. So to the right 2 is our h of x function. All right, next we're going to talk about compressions and stretches, as well as some reflections. So to start, we have our original parent function of x squared plus 1. Notice how x squared plus 1 is intact the whole time, which means this is a vertical stretch and reflection. So the 2 on the outside is being multiplied. It is greater than 1. So for g of x, that is a vertical stretch. Vertical stretch means that it's like pulling this direction. Multiplying by negative on the outside is called a vertical reflection over the x-axis. So vertical reflection means that the function, let's say that this is the function. The function was up like this, and when you flip it over the x, it basically just takes the function and flips it over. So if you're multiplying by a negative outside, it's a vertical reflection over x. Notice the difference between a and b. The 2 is now inside of the parent function. So the 2 that's inside, this is called a horizontal compression, which means from the side of the function, it smushes towards itself. Inside is a negative, which means that it is a horizontal reflection over the y-axis. So what that means is so let's say this is our function. What it's going to do is the function will flip over the y, so it's going to pick up and flip over that way. Parabolas are a little hard to see, so if you're graphing them, you might miss the horizontal reflection because parabolas are kind of equal on both sides. So you just want to be a little careful. All right, on the next one, again, we see our parent function. It is nice and intact in these problems, which means that lots of things are happening in the vertical. 2 is greater than 1, so that is a vertical stretch. On H, notice how 2 things are happening. We have a negative and we have a 3. So the negative is a vertical reflection over the x-axis. And then the 3 is just like the 2. It's a vertical stretch. So 2 things are happening, vertical reflection and vertical stretch. And D, notice the difference between C and D. On D, the values are inside. So the values that you see, the 2's must be written twice. The 1/2s are written twice. And the reason they're written twice is because there are 2 variables, and they each go with a variable. On G, the 2 is being multiplied inside of the function and is greater than 1, so that is a horizontal compression, meaning the function is being smushed from the sides. The 1/2 is also being multiplied and it's inside. This is called a horizontal stretch, which means the function gets pulled this direction. Honestly, if you're having trouble, I would use the chart or I would graph. That's going to be, graphing is going to be kind of your friend on these kinds of problems. All right, so on the back, this is function transformations number 2. I will zoom out so you can kind of see everything. On these, we're going to identify the parent functions as well as identify all the transformations that are happening. Okay. So zooming on in here. Remember, the best way to identify the parent function is to write the function down and then cross out anything unnecessary. So right here, I'm going to just start by doing x plus 3 quantity squared. The way that you identify parent functions is you cross out any kind of coefficient or constant. So the plus 3 has gone away, and you're left with just x squared. So our parent function here is x squared. All right, let's go ahead and identify. So we know our parent function is x squared. Notice the 3 is inside of the function, so that's positive 3 does something. It's going to shift to the left 3. Remember, it's always the opposite direction of what it looks like. Next, we have h. 2 things are happening. The negative outside of the function, because notice in this problem that you can clearly see your parent function of x squared. It is unaffected. So I see the parent function, which means the negative is going to be a vertical reflection over x, and the positive 3 that I'm multiplying by the function is a vertical stretch. So each little piece does something. Next section, we can clearly see an x squared. The plus 3 is outside, so that means that this is just shifting up 3. Again, on k, I can see the x squared. So this is a vertical shift, and it's negative, so it goes down 7. Okay. Again, over here, I can clearly see x squared. The parent function has not been affected. So this number is less than 1, but greater than 0, the absolute value. So this is a vertical compression, meaning it's like the function is shrinking and like being pushed down. On B, notice the difference between the 2. The parent function is not by itself, so lots of things are happening here. So this 3/4, this is less than 1 but greater than 0 and multiplied inside the function. So it's a horizontal stretch, meaning the function is getting pulled horizontally. Okay, on D, the negative is inside of the function, which means this is going to shift it to the right 7. Oh, sorry, I just totally skipped C. All right, so the negative 3 is inside the function and it's subtracting, so that means it's going to go right 3. And then the positive 3 is outside of the x squared function. Even though this is in it, we're going to ignore it to kind of help us with this part. So this is outside and positive, so it goes up 3. All right, let's identify the parent function on the next one. Hopefully it's a little bit easier because you see absolute value, and then I would recommend looking at this problem. The plus 3, if I ignore it, I'm left with absolute value of x, so my parent function here is absolute value of x. This is inside of the parent function, and it's adding or subtracting, so the negative means that it goes to the right, and the number is a 3, so it goes right 3. On H, I see the parent function untouched, so the 1/2 is a vertical compression, so VC, vertical compression, meaning it's shrinking vertically. On J, the absolute value of x is contained, so this is just up 3. And then again on K, I have the absolute value of x untouched, but both of those numbers do something. The 2 is being multiplied and it's greater than 1, so this is a vertical stretch. The 3 is outside and subtracting, so this is down 3. Again, you can always graph these answer choices, graph the functions, and it will tell you what you need to do. Okay, next we have a negative 37 outside of the absolute value, so that is down 37. And then the 3/4 is multiplying inside of the function, so this is also a horizontal stretch, meaning that the function is getting pulled. On option B, I see the absolute value of x. The adding is outside, so this means up 7. On C, I see a negative, and I also see a 2. The negative is outside of the function, so that is a vertical reflection over x. The 2 is inside the function and multiplying, and it's larger than 1, so this is a horizontal compression, meaning the function is smushing itself from the sides. On D, the 2 is outside the function and is larger than 1, so that is a vertical stretch, meaning it's pulled this direction. The positive 10 is inside, and it shifts the opposite direction of how you think, so it goes to the left 10. And on the very last one over here, the 1/2, hopefully it's a little easier to kind of see. The function is the square root of x. That is our parent function. So I can clearly see the parent function is unaffected in G. The 1/2 means that that is a vertical compression, meaning it smushes from the top to bottom. On H, that positive 3 is inside the function, so it shifts the opposite direction of how you think, so it goes left 3. On J, the square root of x is not messed with, so this negative 7 just means down 7. On K, I have a 2 on the outside that is multiplying, so bigger than 1, that's a vertical stretch, meaning it's being pulled this direction. And the positive 3 just means I'm going up 3. When you add or subtract, you are translating, meaning you're shifting the function around up, down, left, right. When you're multiplying, you're stretching or compressing, and if it's negative, it's reflecting. On A, I see the 1/2 is inside of the function and less than 1, so that is a horizontal stretch, meaning the function is being pulled from the sides. On B, the negative is inside the function, so it goes right 7. On C, the square root of x is unaffected, so that plus 12 just means go up 12. And on D, the square root of x is also unaffected, but lots of things are happening here. The negative on the outside is a vertical reflection over the x-axis. The 3 is a vertical stretch, meaning it's being pulled. And then the negative 3 is also outside, or negative 6 is also downside, so it goes down 6. The thing about these values is you are allowed to graph them. You don't have to memorize that chart we did in the notes. Graphing will make these a little bit easier if you graph singly, like graph this one and then graph this one. Then graph the parent function, then graph the next one. It's going to make it a little bit easier. But if you're having trouble, some things to remember. If you are adding or subtracting, you are either going to go up, down, left, or right. Like it's a shift. If you are multiplying, by a number. It's a vertical stretch or a vertical compression or a horizontal stretch or horizontal compression, depending on the location of the number. If you are multiplying by a negative, then it is a reflection. So it's either a vertical reflection or a horizontal reflection, depending on the location. Now, if it's inside the function or outside the function, we'll start there, outside f of x, you're going up or down, vertical, vertical, vertical. If it is outside the function, for example, let me get rid of this. If it's outside of the function, like on this example, g is outside, we're multiplying by a number. It's either a stretch or compression. Okay? If it is inside f of x, inside the function, that would be like this one, left or right, horizontal stretch or compression or horizontal reflection. When I use the term inside the function, that would be like this one. The positive 3 is inside. So each number and symbol will do something to the problem. If you're having trouble, just graph it. The more you do these, the easier these will become.